Okay, in this question, I have to see whether it's true or false that the limit as x approaches 4 of negative 3x squared plus 48 over the square root of 3x plus 4 minus 4 is equal to negative 64 over 3 or not. So before I start this question, I would always check to see whether I can sub in x to be 4 and what happens. So if I just let x approach 4, the numerator is going to be so that's 16 times negative 3 is negative 48 plus 48. And then here I have the square root of 16 minus 4, which you can see is 0 over 0. And 0 over 0 is considered to be indeterminate form, which means that you can't evaluate the limit just by substitution. You have to find another method, an algebraic method, to evaluate the limit. So I know that I can't just let x approach 4 right now. So usually I know that factoring is often involved somehow, and I see right in the first step that I can common factor negative 3 out of the numerator. So I'm going to do that first. And notice I have the limit as x approaches 4 because I haven't taken the limit yet. And then if I common factor negative 3, I'm going to get negative 3x squared divided by negative 3 is x squared. Positive 48 divided by negative 3 is negative 16. And then I realized that this x squared minus 16 is a difference of squares. So it's going to factor to give me x minus 4 times x plus 4 and still have the negative 3 out front. And then now I'm looking at the denominator, which has got a radical. And I know that I can't let x approach 4 as long as this is the denominator. So what you do is you multiply by 1 in a unique way, which is multiplying the top and bottom by the conjugate radical. And the conjugate radical is made by you take the same first and last term. So the 3x plus 4 is exactly the same. And then 4 is the same, but the signs in the middle are opposite. So this one's minus, so this one's plus. If this was plus, that one would be minus. And whatever you do to the bottom, you do exactly the same to the top so that you're really just multiplying by 1. So this is multiplying by 1, which doesn't change anything. You can always multiply by 1. But it's in a way that's going to allow us to simplify and eventually evaluate our limit. So in the top, all I did was multiply everything, and then I put this one in brackets because I'm multiplying this whole thing here. So top by top. The bottoms, I'm going to show you on another piece of paper how they work out to give me this. So, and that's multiplying the conjugates together. So I have the root of 3x plus 4, that's under the square root sign. Minus 4 is not. And then times the square root of 3x plus 4 plus 4. Okay, so that's like multiplying two binomials where you can use FOIL, first, outside, inside, last. So if you multiply the first two terms together, if you multiply a radical by itself, it's like having the radical squared, so it undoes the square root. And that's our firsts, so firsts are done. Outsides is going to be plus 4 times the square root of 3x plus 4. And then if we do the insides, it's going to be minus 4 times the square root of 3x plus 4. So we've done outers and inners. And then the last is negative 4 times positive 4, which is negative 16. And why this is such a nice thing is because you end up getting plus 4 root 3x plus 4 and minus 4 3x plus 4. So those add to 0. So these add up to 0. So your next line down would just be 3x plus 4 minus 16. So that's how you get that. And that's what I had in the bottom when I multiplied this by this. Okay, so I multiplied those two brackets together. I showed you how I expanded it, and then that's what I ended up getting in the bottom. So then my next step, I've got the limit as x approaches 4, and I kept the numerator the same, but I collected the positive 4 and negative 16 because they're like terms and got negative 12. And then I realized that 3x and negative 12 have a common factor of 3. So I common factored out 3 here, which if I divide 3x by 3, I get x. And if I divide negative 12 by 3, I get negative 4. And then I noticed that everything in the top is multiplying, and then these two things in the bottom are multiplying. So I can divide out the x minus 4s, okay? And I can divide out the 3's, but I'm left with still a negative on top. So then if I look at what's left on top, I've got the negative x plus 4, and then the square root of 3x plus 4 plus 4. But in the bottom, I've divided the things out, so I'm just left with a 1 there. So now I'm going to test, can I let x approach 4 now? Yes, because the bottom is just going to stay 1. It doesn't even depend on x. Okay, so we used algebra to be able to now substitute in x is 4. So now that I've done all that work, I can solve by substitution. So now, because I'm substituting, the limit is gone. All right, so now I'm replacing each x in here with the number 4. And then because it's divided by 1, I don't need to show that anymore. And then just got 4 plus 4 was 8. 3 times 4 is 12 plus 4 is 16. I showed the 12 plus 4 plus 4. Root of 16 is 4 plus 4, so I end up getting negative 8 times 8, which gives me negative 64. But if I go back to the question, I was supposed to say whether it was true or false that the limit was negative 64 over 3. So if everything I did is right, then this statement is false, okay, because we just proved that the limit is actually negative 64.